So here we have a JEE Advanced question, and say it's a mixture of 2 moles of helium gas, where they're giving us our atomic mass here, this is 4 AMU, and 1 mole of argon gas, where the atomic mass is equal to 40 AMU, is kept at a 300 Kelvin in a container. So that's our temperature, and it's kept at a constant temperature in a container. The ratio of the RMS speeds is V1 is VRMS of helium over VRMS of argon. So the first thing we understand is that the VRMS formula, I'm going to write it right on the left-hand side here. The VRMS formula is basically equal to the square root of 3 times the Boltzmann constant times the absolute temperature divided by the mass of one molecule of gas. So the ratio we need to find is VRMS of helium over VRMS of argon. So this formula can basically be written for helium and argon like so. I'm going to be showing all steps. You don't have to do all these steps. Try these questions as quick as possible, but I'm going to show all steps, right? We want the VRMS of helium, which is basically going to be equal to the square root of 3 kT over MHE. All right? And the VRMS of argon is going to be equal to the square root of 3. Remember, this square covers the entire thing, by the way. So just note that. My square roots are really bad. Over MAR. Okay? So something really cool happens. This 3 kT, when you're finding the ratio between these two, these 3 kTs are actually going to cancel out in this case. So when you write it out, what's going to happen is when we get the VRMS of helium over argon, so when I do VRMS of helium over VRMS of argon, we're going to basically get the root of this, right? So 3 kT is common and it just cancels out. And we're just going to get the mass of an argon molecule and the mass of a helium molecule in this case. So it's going to be argon over helium. Okay, so let's just use our formula to solve this. So our argon, 1 mole of argon gas they've given us is 40 AMU. So basically it's going to be square root of 40 over a value of 4, because they say that 2 moles of helium gas is equal to 4 AMU, right? So this is going to be equal to a value of root 10, and that's going to be equal to 3.16. So the answer in this case is 3.16, which is D.